So I'm Jeff Balcerski. I'm an assistant professor of aerospace engineering in the College of Aeronautics and Engineering. So when I nerd out, I like to really nerd out with the space theme. This presentation is going to be discussing human habitation in space. So to give you a little bit of context, as some of you are probably aware, NASA is in the middle of this Artemis campaign to send astronauts back to the moon for extended periods of time. We're only in the beginning stages of that, but the ultimate end stage of that campaign is that by the beginning of the 2030s, NASA and other national agencies intend to have permanently inhabited large-scale lunar habitats. So by large scale, I mean multiple habitation modules, operators, astronauts there all the time. We can expect that those duty shifts would be on the order of like 6 to 8 months, comparable to what like a nuclear submarine crew would experience, an Antarctic research crew might experience. So very austere conditions for extended periods of time. There is a lot of heritage in living in space through operation and inhabitation of the International Space Station for the last couple of decades. But living on the moon is likely to be very different with very different risk factors. So it'll really combine the isolation of, living under sea for extended periods, or living in the austere Antarctic or a desert environment or whatever, with a very, very high risk environment of being in space exposed to potential high radiation events, no atmosphere, intense heat, intense cold, and all the other things. So the genesis of this project really is to explore the living environment that astronauts can be expected to experience. And that's really for a couple of reasons that I'll get into in a minute. But the initial habitats are these very small modules, right? They're basically large tin cans, they're large submarines, and they can have a variety of configurations. One configuration is this vertical configuration that you can see here on the right. Another configuration is a more traditional horizontal configuration there on the left. But in either case, you can see that the initial plans in the next decade are for very, very confined spaces. We are not at this point talking about large cities on the moon. So examining what the interior of one of those modules might look like, this is the Orion space capsule. So this is what the astronauts in Artemis 2 that just went around the moon into deep space. This is the environment that they lived in, and this is about the size of what we can expect for the initial lunar habitats, because they're built on the same framework foundation. So for comparison, like a nuclear submarine bunk, this is taken from a British nuclear sub. Very, very Spartan conditions, right? The whole thing is a tin can meant to resist the pressures, the ocean pressing in on it, of course, because it's underwater. Well, you have the same configuration in reverse for lunar living. You're taking the pressure inside and resisting those forces outside. In both cases, it's a tube. Right? And then for additional comparison, this is the bunk room from an Antarctic research station at McMurdo Base. Okay, so there are some initial designs for this. This is like 3-story vertical configuration. This is one of NASA's designs, a 3-story living level, but barely enough room for like 2 people to stand and not like run into each other in each of these 3 levels. So everything is super compact, workstation bedding, everything else. So it's kind of the question, and it's just NASA animations of like into the 2030s, when you start assembling modules and you start building up this like long duration lunar presence. But my question is, what are we driving toward? Like, why does it matter if it's just a onesie twosie, if it's just a one-off lunar module? Well, it's not too far of a reach to say that where we're driving to is full colonies full cities eventually on the moon and Mars, right? This is frankly exactly what Elon Musk is talking about there with the human race, making it uh, a multi-planet species, right? But the takeaway message is that a single habitat module, one module, is effectively the atomic element of all space settlements. If we want to know what the living conditions are in space, then we start with a single module and ask, what is the environment that the astronauts need to live in there? How do they deal with 1/6 normal gravity, which is neither zero gravity nor full Earth gravity? What are the other environmental considerations of living on the moon? Such as dealing with changes in pressure, changes in oxygen, changes in sunlight that affect circadian rhythms and everything else. In addition to the psychological effects, right? So this is a question that by nature crosses all disciplines, right? From psychology to engineering to fashion to human health to ecology to everything, architecture, interior design, you name it. Because I mean, taking hubris aside, we're talking about creating a new culture, like a new societal circle on another planet, right? So the object of this exercise, or my proposal was to explore what that might look like in that atomic element, that space habitat. So in order to do that, I propose to create a 1-to-1 scale walk-through lunar habitat module. And there are kind of two motivations for doing this. One is education, just to say to just to show the general public, hey, these are the considerations you may not have thought of. It's just kind of to generate a conversation about what it means to live in space, what it means to live on the moon. But the other motivation is that I believe that in order to do effective engineering, coming from an engineering perspective, you have to be in the space. You have to design for usability. I mean, if you've ever changed the oil filter in your car, right? There's a special oil filter wrench. But if the person who designed that wrench had never changed an oil filter, had never gotten up and done like the contortionist thing around the engine block to change the oil without getting it on their face and stuff, then they just wouldn't know how to design that tool. So the same thing is true for designing for other environments, just like designing for space. Designers need to be in an environment that is as closely approximating to the environment that they're building for as possible. So that's the second aspect of building this module is to let people be in that environment designed to it. It's sort of inspired by starting with the idea of sort of a museum installation that people can walk through and do like very tactile, interactive experiences with it. But rather than a passive installation, one that again lets people experience as closely as possible those living conditions. All right, so diving into kind of the technical details. So I'm gonna point over to the side here, and this is the first unit of what is actually a spatially reasonable approximation of what a lunar module would look like. And, well, these people can't see it, so I guess they won't know it. But it's basically the same thing. It's basically 8 feet wide, so it's just longer than my wingspan, right? And about 8 feet high. So you can operate in there, but I'm not really entirely sure that it would be a great place to live for 6 8 months, a year, or longer. So the question really is, so I'll run over here just to give a scale. The question really is, how can we take something that is this size of not even as big as a camera, right? Take something that is that size and turn it into something that not only protects human life in terms of making sure that astronauts don't die, but does it in a way that is conducive to a healthy human lifestyle, because we're talking about long-term living. All right, so just to get into technical details, I went down a big rabbit hole of how do you create arches. I thought it was a simple thing, you just stick 2 curves together. Turns out I'm not an architect, and the architects probably know that there are like a million ways to create arches. But was actually pretty happy that I managed to create an arch that's pretty stable. So this is just like a dual tangent, single circle arch. The walls are 6.5 inches thick to give it a little rigidity, and it's kind of supported by that the lateral supports of that melamine that's bolted onto it. But I haven't tried it yet, but I'm pretty sure that I could hang from the middle of it, just like two jumps. I may try it. We'll get it on YouTube later. But yeah, so I'm pretty confident with the way that has turned out so far. And this just kind of goes over the elements of construction and how I had planned it out. It actually turns out that it was pretty close to being to the initial plan. If you go and walk around it later, what you'll see is that each of these ribs is actually two pieces of 1/2 inch OSB that are blocked together with 2x4. So that sandwich of OSB, 2x4, OSB actually makes those side panels pretty strong. Just very quickly, materials list for the structure. I just kind of went over that. So about $100 for the materials, and then what I anticipate, I haven't quite gotten into this phase yet, but once it's furnished with all of the installation materials, all of the audio effects, I've got a couple of porthole screens that we can cut windows into it. You'll see like the lunar surface, again, is to as closely approximate the light in the lunar module as possible. We're probably talking like per 4-foot section, about $380 in materials, which isn't terrible. So ultimately, this installation will have probably 2 more of these sections to go, 12 feet long. So we'll have a 12-foot by almost 8-foot by almost 8-foot. I haven't even keep track of time, but I'm assuming I'm getting close. So focus areas that we want people to take, like the takeaway messages are what is life like in this particular space? What do people eat what are they going to eat when they live on the moon? Is it the same as the astronaut food that they use on the space station? What about hygiene? Can you take a shower on the moon? Well, maybe it's 1/6 gravity. So, like stuff falls, but it doesn't fall really well. So showers make sense. I don't know. These are kind of things about daily life that as engineers, we kind of skip over and go, well, the astronaut's alive. Isn't that good enough? Well, for a society that we're building on another planet, it's probably not good enough, right? Sleep and comfort. I don't know. I toss and turn in my sleep. If I do that in 1/6 gravity, am I going to kick myself right out of the bed? Probably. Ambient light, sound, smells, etc. Astronauts reported that the surface of the moon actually smelled like the dust regolith, smells like gunpowder, which is sort of interesting. Ambient light, we're talking about living near the south pole of the moon. So the light is, depending where you are, almost constant and very, very harsh at a very, very low angle. If I go back to real quickly to the NASA image here, you can see it's a very intense low level light or a low angle light that's casting these long, intense shadows. So how do we mitigate those light effects from things like circadian rhythms? All right, I've also been tinkering around with additional bits to the installation because I want to make this as multi-sensory as possible. There will be audio effects sort of built in to give a sense of machinery running, pumps running, gases moving around, liquids being pumped, et cetera, et cetera. Olfactory, I mentioned the gunpowder. We can do some like haunted house special effects with like the scent diffusers. So we're really like pushing the experience as close as possible without having to go through astronaut training, to letting people get a sense of what's there. And then just really quickly, it's been like, how do you run this whole thing? The operator, not the operator, but the sort of behind the scenes show, we'll call it the show runner, can actually use something called Node-RED. Node-RED it's like a programming language for IoT. It's basically event triggers that causes something else to happen in a pre-programmed sequence. So we can trigger all those sounds, we can trigger the smells and lights and everything else. So it is sort of a little bit of, no, it's a lot of showmanship, but that's okay. That's how we get people into this user experience. So I imagine that this will be a very open, basically open to user-paced nonlinear experience. So wherever we end up setting it up here, it'll be open for a while for people to just simply walk into. There will be sort of an introductory sign at the beginning, and then they'll be able to explore that space with signage around, encouraging people to think about specific aspects of life in this lunar habitat. This spring, the student chapter at Kent is sponsoring is hosting the regional AIAA meeting. AIAA is the American Institute of Aeronautics and Astronautics. So that meeting will be here, and also we're planning on doing sort of a reception in this area where we'll introduce, sort of have a grand opening for the installation, and just kind of use that as a centerpiece for conversation with that reception. I think the last thing is timeline. We're sitting about right here with this minimum viable product. This single unit arch has been created, gone through this initial design study. Now we're going to start adding in the sensory components. And the nice thing is that now, as we get back into the semester, some of the people that I would have liked to have worked with the summer will be back. Some of the theater and architecture folks will be back. So I'm looking forward to that enhanced collaboration throughout the fall, and then kind of getting the final pieces and all the last integrations in as we approach mid spring term. And then again, I'm looking forward to a grand opening in March. So that's it for me. I probably went over time, but I'm happy to take questions. Thank you. Thanks.
See like the future of this? Like, are you gonna have it permanently somewhere, or like what do you see happening like with this?
Yeah, so bare minimum, I intend to use it for teaching. Like I would hope that some of the collaboration fostered through the DI Hub would allow other people to use it also, right? Like I would love to see architecture or interior design come in and say, even if they're just like spend an hour thinking about, well, what does it mean to design for confined spaces dramatically from environments? I think that would be super cool and a good use of it. But for my own purposes, my students' purposes, NASA hosts or sponsors design competitions every year on lunar infrastructure, lunar living, astronaut health, that kind of stuff. So we would use this as a base point to do those designs and kind of leverage that in the competition. Hey, Tarna.
Oh, hi. Thank you so much for your presentation, and really cool shirt, by the way. You matched.
Thank you.
So I have a question about the urban aspect that you showed in the rendering that you had. That was super interesting for me. And I just wonder, this might be very stupid question. I don't know much about, kind of lunar cities, but in that, image you showed kind of, sort of the vision of the city to be polycentric rather than sort of centralized. So you had multiple nodes. Is there a reason for that? That's very interesting.
Yeah, I'm not sure how much of that. I don't think that there's been a lot of real design that's not science fiction in terms of what those city structures look like. There has been some initial work, but you can kind of go down two paths. One is that there are isolated population nodes for safety that should any one of them have a catastrophic event, the others are protected, right?
Yeah.
So that is one path. The other path is that for efficiency and for resources, it's much better to do a hub and spoke model where you just start from the middle and build your way out. So, again, I take it all with a grain of salt because it's really at this point kind of speculative and science fiction, but this project is exactly the kind of thing that I feel like we need to explore in order to make it less science fiction and more science. Like there are actual concerns that we need to think about.
Yeah, but that's super interesting. Like, what would be the infrastructure, in a city like that? How these individual units going to be connected, if they're going to be connected? How we can create a community? These are really interesting questions, but very great presentation.
Yeah,
Thank you.
it's a big, long rabbit hole. A big, deep rabbit hole. The more questions, the more questions. Yes. Thanks, Tara.
Sounds good. Thank you.